Welcome to Smart Software with Smart Logic, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justice Epen, and I'll be your host today. I'm a developer at Smart Logic, a Baltimore-based consulting company that has been building web and mobile software applications since 2005. I'm joined by my colleague and fellow alchemist, Eric Ostrich. Eric, say hi, buddy.
Hello, everyone.
So this is season 2 of Smart Software. And on season 2 of Smart Software, we are going to be talking about Elixir internals. We're going to be talking about the inner workings of Elixir or the inner workings of popular Elixir libraries, common Elixir libraries that we can learn something from. So, with that all being said, today we're joined by Brooklyn Zelenka. Brooklyn, how are you doing?
I'm doing well. Thanks for having me back.
We are so glad to have you back. You were the first ever interview that we did on season 1, and you are now the first person that we're interviewing for season 2. Now, these sometimes come out of order, so it might not be episode 1, but I think it's really cool that you're back for a second season, and I wanted to call that out.
Yeah, thanks.
Now, let's start from the beginning. Brooklyn, can you just introduce yourself for the audience? Tell us a little bit about your background, the company you work at, how you got started working with Elixir.
Yeah, sure, absolutely. So I'm Brooklyn, as you mentioned. I've written a number of Elixir libraries and used to do corporate training for companies doing Elixir. So I've written, one I'm most known for is Witchcraft Suite, so Witchcraft, LG, Quark. There's a few others. And the one that most people use is Exceptional, which is a happy path error handling in Elixir. I'm the co-founder of a company called Fission. We bring decentralized web technologies to wider development community. So instead of focusing on the people that are already doing IPFS and Ethereum and all that stuff, we're helping everyone else integrate that seamlessly in a way that they don't have to worry about all, how everything inside works. Kind of like a decentralized Firebase almost. Today, these days I'm working mostly with Haskell, Rust, and Elixir, both for web and doing some compiler work. The compiler stuff mostly because I'm an Ethereum core dev. I've done some standards work there and have been working on improving the virtual machine, the Ethereum virtual machine, which a lot of that gets done in Haskell and Rust. And how did I get started with Elixir? So early on in my career, I got interested in functional programming, like literally a couple weeks in. Started out with Scheme and then Clojure, and then discovered Erlang. Played around with it a bit, didn't go too deep. And a couple of years later, had a roommate who had contributed to the original Elixir when it was still macros on top of Erlang. And he was really excited about Elixir and got me into it. And so started playing around with that. At the time, I was doing mostly Rails. So playing around with early, pre 1.0 Phoenix. I started writing some simple libraries. I was running the functional programming meetup here in Vancouver at the time. A lot of people wanted to learn functional programming concepts, but didn't want to have to learn Haskell or Clojure. And everyone here was really excited about Elixir. So started writing Quark to introduce some basic concepts in Elixir to kind of get people, having both at the same time. And then eventually ended up getting a full-time Elixir job for a couple of years. And then eventually did teaching and talks and more software as well.
So we want to dive a little bit into Witchcraft, which you've already mentioned a little bit. But before we do, you've contributed to so many libraries, and we want to pay a little bit of homage to open source. Can you tell us a little bit about how you got started doing open source, and maybe how has contributing to libraries written by other people influenced your opinions and software development patterns?
Yeah, absolutely. So open source has been kind of in my DNA from day one. It's really this is uncontroversial, is what makes software run today, right? And contributing back to libraries both forces you to read how other people are writing code and collaborate with other people in a way that, it's technical conversation, but also exercising that, more social muscle too, right? Reading through other people's code, deconstructing it, not getting locked into how your company does things, I think is really important, and to see how the wider community works, and getting as much exposure as you can to as much code in as many languages ideally, but even in just Elixir really helps broaden horizons and kind of, you pick up tips and tricks along the way. So I started contributing to open source, probably maybe a couple months into my career, just contributing back patches to things like, I found a bug, or changing the docs to make them clearer, that sort of thing. And then eventually taking chunks of software that I was writing at work. I said, this is reusable. Could I take this under an open source license? Yes, great. Let's section that off and make that shared so that nobody else has this problem again in the future. And actually, most of my open source has ended up in that pattern of, I have a problem at work, I'm going to put a pause on this right now, and then let that out and work on it and make it a reusable thing.
We actually had a question that we were going to ask about how your employer at any point in your career has empowered you, and we took it off because we thought it wouldn't be as interesting of a question to ask because you run your own organization now. But I think actually you sort of mentioned, like, how did you get that working relationship where you could spend time on open source?
Yeah, so it depends, as you mentioned, very much on the employer. So in some cases, especially small startups where there's more of an ideological interest in open source, very easy conversation to have. Hey, could I spend a bit of time working on this thing? We need to write it anyway, but could I then open source it under a license of some kind? Ideally, something very permissive, right? Other times, it's if you're doing client work, right, shipping something for Amazon or Facebook, that's less flexibility there typically, right? Other than the things that they want you to write for an open source project, everything else they want to own, right? So I would hit a problem and say, wouldn't it be great if something like this existed? I'm going to put a pin in that, work on this other task, and then on my weekend write the thing and release it in my own time, and then include it as a dependency.
Yeah, I've also done that. That's a great tip.
Yeah.
Well, maybe we should jump into witchcraft.
Great.
Brooklyn, do you want to just give us the witchcraft 101? Maybe tell us where the best place to start is.
Yeah, absolutely. So witchcraft is both the name of a single library and also the title for a suite of libraries that work together. The tagline is Monads and Other Dark Magic for Elixir, which is a little bit tongue-in-cheek because it's more than just monads. It's sort of, when people think of functional programming, they think of lots of mapping functions and, certain things like, identity and constant functors, combinators and having functors and, all this other stuff. So bringing all of that into Elixir to have these more structured abstractions that you would find in a language like Clojure or Haskell or Elm that I was surprised didn't exist in Elixir when I showed up. So the best place to start with it is to go directly to the docs. So if you go to hex.pm/packages/witchcraft, that'll get you the installation instructions, all that, the main page. You go into the docs. The README is fairly extensive and kind of gives you a little orientation. And then jumping into, say, witchcraft.functor is a nice place to get started for data structures. Like, let's say you want trees, that sort of thing. There's a companion library called algae, short for algebraic data type, that has trees and eithers and maybes and all of that stuff in it. The docs are written in such a way to be explanatory so that there's kind of half a teaching tool and half for production work. So a lot of people get confused about what are all these abstractions like monads and functors.
I was just about to ask, treat me like I'm a 5-year-old.
Yes. Yeah. So the idea here is just like how, we're all very familiar with enum.map, right? And that's more structured than writing a loop yourself or doing the recursion yourself directly. You can say, this is a map. I know that I will always get back a list of the same length. Right? And I will just have run this function over each element. That's the same general idea, but we've added more layers of abstractions on top of that. So in witchcraft, there's a couple different of these towers of abstraction. The most popular one by far is this tower called functor. And so a functor is the mapping function and some helpers that go with it. And in such a way that it'll always return you the same data structure. So enum.map will convert things into a list. Functor.map will return you, if you give it a list, it'll give you a list. If you give it a tree, it'll return you a tree with the same structure. You give it a struct, you'll get back the same struct. Right?
Okay.
But the difference is what's changed inside.
And functor, where does this term come from? Is this a lambda calculus term? Is it a functional programming term?
So it comes from category theory, which you do not need to know any of to use these abstractions at all, right? It is the term for, in the sorts of things that most people will be doing, you can think of a category as essentially a set, and it's the mapping from one set to another, basically. Okay. That's like the really watered down version of it.
A functor is a mapping from one set to another set.
To another, yeah, for sets, right?
Okay.
So it's saying I have a list of integers and I'm going to turn them into strings. Now I have a list of strings. So I had before a set of integers. Now I have a set of strings.
And so the intermediate algorithm is the functor.
Yeah, the design pattern is the functor, saying that we're going to retain the structure, the ordering, all of that stuff, but we're going to change the contents. We're going to do something to the contents inside. So instead of having a book of design patterns like you get in object-oriented programming, with functional programming, we can take those and turn them into functions and give them a name. And now that's our design pattern. Map is a design pattern.
Okay. So I'm looking right now at your GitHub and Witchcraft and the type class hierarchy. And under functor, we've got these terms: traversable, apply, bifunctor. Under those, we've got applicative and a chain. And then, but at the very base of this hierarchy, you've got a monad. Now, the very first word is monads and other dark magic. Yeah. What is a monad and how does it relate to a functor?
Yes. So monads, the reason that it's in the tagline is because there's a bit of an obsession with them in the functional programming community for two reasons. One, they're very, very powerful. And two, they're difficult to explain. So I'm going to do my best. The reason that they're difficult to explain is because they do so many different kinds of things, right? The general pattern, it's the essence really of Turing completeness for things that have dependencies in them. So you're saying that I'm going to, have a variable A, assign something to it, and then B that depends on A, et cetera, right? And we can write something abstract in this way and say, just like how maps can work on these different containers, so can monads. In fact, a monad is a powered up map function. It does some extra stuff. So one, it has this ability to have dependencies between first thing in the list and the last thing in the list and how they've changed. It can change the structure based on that. And the third one is it might run some other, what we call an effect. So if you have, there's a structure called a maybe, for example, which is as it's done in Witchcraft, it's either an empty struct, so a struct with no keys to represent no value, basically a nil, or a struct with one value in it, right? And if you map onto this, functor.map onto a maybe, onto a nothing, you get back just nothing. If you map onto the just side, the one with the actual value in it, you get back the value mapped inside the structure. In a monad, you can say, I'm going to do this across a whole bunch of things that might be maybe, and if I ever hit a nothing, just short circuit and return me the nothing. I don't have to go through all the rest of these steps. Right? So you can run different kinds of effects. Lists can be seen as non-determinism. You're saying, I'm going to run this with any of these inputs. And what will I get out? Well, I'll get back any of these possible outputs. So you can model non-determinism. You do railroad programming. A really interesting one.
What is railroad programming?
Railroad programming. So with structure in Elixir, you have the with do. And if you ever get back an error in the tuple, you short circuit and you go down to the bottom. That's railroading. So you go into the error side of this railroad. Otherwise, you're on the happy path. And you can focus on the happy path. One thing that I think is really interesting for Elixir that I've done that I think more people could get use out of is automatic logging. So there's a monad called writer. So it's a data structure as well as has an instance of monad as a protocol. And when you run these functions on it, you get back, it does the actual regular function, right? But it also appends to a hidden log what's happened. So you can have regular logging, but it travels around with the data structure. So you can take this thing, stick it in a database or send it over the wire, and the log goes with it. You can save it into a database for a year, bring it back, and the log is still there with it as it was the last time you touched it. Or you can send it to an actor on a different node in the cluster, and the log goes with it, which is pretty handy.
So I'll be totally honest, it's a little bit over my head. So I'm going to ask some questions that might help me or maybe someone who's simple like me to understand. So first of all, I asked you earlier, is a functor or functional programming thing? And you said it's a category theory thing. Yes. Is a monad also, like if I go and research category theory, am I going to end up at an understanding of monads?
You will.
Okay.
The way that they describe them in category theory is they tend to use, in Haskell in particular, they tend to use a lot of mathematical terms. And there's two ways to see these things. There's an engineering perspective. What can I do with it? There's the mathematical perspective. What does it mean, right? You don't need to know the mathematical side to use it. You can say, here's some tools, here's some design patterns that I can use. I can have a data structure that logs all of its updates. I can do railroad programming. I can do non-determinism in just purely engineering. These are tools in my toolbox. If you happen to be interested in the math, you can go dive into them. But this is also partly why I think people get so wrapped up about some of these concepts is like, oh, it's called a functor. That sounds scary. No, it's just a mappable thing. If they called it mappable, it wouldn't be scary.
Right.
Right? Yeah.
So do you have... Like the other thing I'm looking at here is that you've got the functor, and between the functor and the monad, you've got two levels of hierarchy. If I understood, so like now I feel like I understand a functor, or at least a high level concept, would I need to then also understand traversable, apply, bifunctor, applicative, chain before I could understand the monad? Or do I really just need to understand, based on this chart that I have here, that I wish our podcast had video so I could just screen share this, but it looks like I might actually only need to apply or understand the apply, the applicative, and the chain.
Yeah, exactly. So the arrows that are pointed down in that, so there's a little tree, there's some arrows. All monads are applicatives.
Okay.
All applicatives are functors.
Okay.
So just like how you have a class hierarchy, these are called type classes. And in fact, I had to bootstrap that in to Elixir in a library called type class.
Okay. I'm really sorry to derail the whole conversation just on this category theory digression, but I actually think it's really important because it does seem to be what witchcraft is aiming to teach people. Is that right?
So it's not aiming to teach category theory per se. It's trying to bring these kinds of abstractions, these structured abstractions, into Elixir. So the ones that really surprised me that weren't there were things like identity, which is like category theory can let you express literally anything in math. It's almost the mathematics of mathematics, right? So it's very abstract. Identity, having a function that just returns its result back all the time, is like bread and butter in functional programming, going back to the 50s, right? I was just surprised that it wasn't there, so I stuck it in Quark, right? Same thing with second. So you take a tuple and you skip the first argument, right? Some little things like this that you would kind of expect that aren't there. And so things with names. And then for Witchcraft, the library, it's these structured abstractions like having a map that will return me the same structure without having to convert back from the list by hand every time. And then other little things, like the other thing that Witchcraft gives you is guarantees about certain properties that your data structure has. So I can do things like async map. So take a map, shove all of them into tasks and run them. And it's one line. You don't have to do all of that by hand yourself. They just have a name, and it works the same way as map. It's identical. It's just asynchronous. And we can do that because of these properties.
Okay, this is really helpful because my next question was about, how does Witchcraft and all these other libraries that you're developing, like what is the unified purpose? And it sounds like you actually sort of just explained that, which is, there are these structured abstractions that are very useful to programmers that aren't available in Elixir in the standard library. And so you're trying to provide these. Is that right? Because if it is, then Eric can get to asking some of his questions before we run out of time here.
That's exactly right. Yes.
Okay. Eric, what do you got for us?
All right. So I got some help on these next few questions. I'm not sure I fully understand them, but let's give them a go, right? So the first one we'll do is, so witchcraft technically doesn't provide the full mathematical formal correctness of Haskell. So languages with Hindley-Milner type system remove a category of errors from being possible at all, thereby allowing different tests to be written. How likely are the holes to accidentally be a problem for a non-expert in category theory or for someone who is used to more formal correctness of, say, Haskell?
Yeah. So it's a good question. I'm going to expand some of that out
Yes,
for
please.
the listeners a little bit. Yeah. Okay. So Hindley-Milner type system. This is the type system you find in a language like Elm or Haskell. It was designed really to provide type inference. It's the original goal. And people started, and so that you wouldn't have to write your own types. But people started finding that types were a useful thing to have as annotations to help them think about things, right? So Hindley-Milner is very popular. There's this definite rise. TypeScript is borrowing stuff from there. There's definitely a trend of adding that in. What it also gets you in a pure language, so not TypeScript, but in Elm or in Haskell, is something called propositions as types, or Howard-Curry isomorphism is the technical term, right? Where you can see types as propositions in a logical system, and your program is a proof. So you are literally writing a program that is a proof of itself, which is pretty wild, right? Which then means you don't have to write tests. Proofs are much better than tests. The tests just say, in these cases, this works. A proof says, in all possible cases, this works. So you end up writing fewer tests, basically. We don't have a type system in Elixir baked in with that level of strength. And I don't think that we ever will. And I don't know if that's a good idea to add one with that level of granularity, right? We could, but you'd also have to capture all of the side effects. So all of your calls to a gen server, all of your network calls, all of the disk stuff that you do, right? Which is some overhead and a very different way than we think today in Elixir. Not to say that there isn't value to these things. There's something else called contracts, where you just say, these are the inputs and these are the outputs, and I don't care what happens in between if there's side effects. Go for it. Already useful. But you really get this power when everything's fully typed. So we don't have that. Why even have these abstractions like functors and monads in Elixir? They're still useful. You just have to be your own type checker, right? You have to say, I'm asserting that these things work, even though I don't have a computer checking for me that the things work the way that I say they do. As an attempt to fix that in type class, so one of the dependencies that I wrote for Witchcraft, we do property-based checking at compile time, which is why Witchcraft takes forever to compile the first time. So your first run with that as a dependency will take 5-6 minutes.
Wow.
Yeah, it's
I've
long.
never seen
And this
anything
is
in Elixir take 5 or 6 minutes. Wow.
Yeah, no, it takes a really long time to compile. And that's also, by the way, my biggest regret in this suite is enforcing this correctness. We do, you have to specify properties, and then it runs, I can't remember, 10,000 checks by default on every property for every data structure that it's designed for. So it takes a while. Now, it does get cached, so that's just the first time. But what I should have done, and what I do plan on going back in and doing, is turning those into test generators so that people can write them for their own test suites, right? It doesn't have to run for everyone on compile that list works the right way. I know list works the right way. I've compiled it a bunch of times, right? So this ends up being a deterrent for some people. Bringing in the dependency is like, wow, suddenly things are taking forever to compile. So today it's just the first time, and yeah, it's going to get changed. So yes, anyway, that's a digression. Back to why we would want these things when we don't have a strong type system. Because these abstractions are still useful, I still want to have a map that returns back the same structure that I gave it. Right? I still want to be able to write a library that does error handling with eithers, right? So that I can do this automated railroad programming and only think about the happy path. There's a lot of stuff in there that's really helpful for library authors in particular, because you can write just abstractly functions and it'll work on any of the data structures that come in that have the instances for a functor. So you can take LG for the common ones and it'll just work automatically with all of them, plus the built-in data types. and it will have these effects, these different effects based on the data you hand it. So you can start writing some very, very powerful libraries with these structures. You just have to be careful in a way that Haskell would have stopped you from doing. You have to just write your tests for it.
But you have to be less careful than if you didn't have Witchcraft and you were just writing vanilla Elixir.
Yes,
right? That's
exactly.
the idea.
Yes.
Okay.
Yeah. But what we have is prop tests, which means we test it with whatever 10,000 random values, which is great, but it's not a proof. It's just 10,000 tests, which is better than what most people write anyway.
Yeah, for sure.
No comment.
So I guess, is there any way so we have a type system, I guess you could call it already, called Dialyzer or Dialixir, I guess. Is there any way to, I don't know, help merge them together and like make everything better?
Yeah. So Dialyzer, you can add annotations for Dialyzer out of the box. They're there. You can write them for your own functions. Problem with Dialyzer. So two things. One, yeah, it has a type system. It's not super strong and you can lie to it. It also has something called subtyping. So you can just say, hey, this is an anything. And it was like, cool, great, that's anything, wonderful, right? The point of Dialyzer is a static analysis tools. So type system is one kind of static analysis, but they do a bunch of other things, right? They do case checking, they do, unreachable code. Like there's a bunch of stuff in there beyond the type system, which is all great. But could we strengthen the type system specifically in Dialyzer? You could. I don't know if it's improving the type system of Dialyzer would be valuable, yes. Sticking in a full, pure Haskell style type system into Elixir, you're starting to write something that's not very Elixir-y. There are languages on the beam that do this. Alpaca Lang is one, which is it's in the same family as Haskell and Elm. Even your actors are typed, which is pretty cool. But should Elixir itself be typed? I don't know. There's definitely still value in softly typed or dynamically typed languages. Scheme has been around for a while. Clojure is doing quite well. Look at all the untyped OO languages. There's still value there. It's just, it's not going to get you proofs.
Right.
So I think more Dialyzer are great and making it this optional thing, cool. But until you won't see the value of a proof until you have 100% of everything typed and pure. And, it's one of these things that has exponential returns. If you type part of your program, like, a module, you're not going to see much value. If you type 100% of it or 99% of it, you get a ton of value. So it's one of these things where Elixir would have to change significantly, I think, for that to make sense.
Wow. Well, Brooklyn, we've got more questions here, and we're also pretty much at the end of our time. I think that it would be amazing if we could get you back on the show at some point. Before we let you go, do you have any final plugs, asks for the audience? Where can people find you? How to get involved, support any projects you're working on? Yeah, please share with us.
Yeah, absolutely. So if you'd like to sign up for the stuff that we're building at Fission, go to tools.fission.codes and sign up, and you'll get a handy little email when we start shipping our first products. I'm always available online at Expede, EXPEDE, basically everywhere, GitHub, Twitter, so on. I'm available by email, hello@brooklynzelenka.com. Witchcraft has an open collective. So this is both a plug for, which is a Patreon-like service for open source projects. If you're interested in supporting Witchcraft, go there, donate, great. If you're a library creator, they've reached out a couple times now and said, hey, we really like Elixir in particular, like their devs. We'd like to get more Elixir projects on the platform. Right now they have Witchcraft and Nerves, which are pretty much the opposite ends of the spectrum here, right? Sign up for Open Collective. It's free to do, and then people can donate to your project to help support the work you do, in your evenings and weekends, which is great. Witchcraft itself, obviously, you can find on Hexdocs and on GitHub, and always happy to answer questions about it. Again, Twitter, email, or directly in the GitHub issues.
Great. Brooklyn, thank you so much for joining us today. I know that our audience is going to get a ton out of this new season, and this is just such, I mean, for me personally, this is such a great way to kick it off. So if you want to say goodbye, thank you so much.
Thank you.
Once again, this has been Smart Software with Smart Logic talking about Elixir internals. Join us next time to learn more about libraries and the inner workings of Elixir.